Hey guys, this is Mr. Balint. So I'm going to do neutralization for this video. Some classes might have done it, some classes might have not, but I just want to get a video here just so that everyone kind of like has something to reference and can understand it for when we go over it super quick. You should have a couple pages in your packet. I think this one starts on page 7 for you guys. So it should say Topic 3, Acid-Base Neutralization, and it should start right away with just a couple of blanks. That's what I'm going to be looking at for this video. But yeah, other than that, just try and follow along. If you have any questions, just save them for when we get back to school. But yeah, let's get right into it, I guess. Here, hold on, let me get... I had a lot of fun at the beach because I wasn't doing work. Okay. Cool. Okay, so acid-base neutralization. The first thing that you should probably notice about the word neutralization is that it has the word neutral in it. Now, it sounds kind of silly to say, but I just want to make sure that we all kind of like see that right here before we start. The whole purpose of neutralization is to combine multiple things to make something neutral. If you're not 100% sure what the word neutral means like balanced or even, or some people say zero. The idea is that when an acid and a base are mixed, the H plus ions of the acid, so here I'll just write. So the H plus ions, and again, I'm kind of not going to be able to stay in the lines here, so bear with me. The H plus ions of acid and the OH minus ions, oh boy, there we go, sort of. Ooh. The OH minus ions of the base combine to form water. And that should kind of just be a review, just as a really quick reminder. Like if I take H plus and I add it to OH minus, that should yield H2O, or water, like that. Notice that the plus and the minus even themselves out to make neutral water, and that I still have two H's on the left, two H's on the right, one O on the left, one O on the right. The idea is that when you combine an acid and a base together, you make neutral water. That isn't the only thing that you make, though, because, as we know from doing the ionizations in class, you usually wind up with something extra, some extra stuff. The shorthand ionization usually shows you just the acid and the base being mixed together to make water, but the rest of the equation usually will form some sort of salt. That's super, super important. In order to understand what neutralization means and how we do it, you have to remember that when you have an acid and a base mixed together, you make water and you make salt. Water and salt are the products here. Two very important things that we've talked about practically all year, water and salt. At this point, we should kind of be familiar with what salt is, but just in case we're not, I'm just going to really quick just highlight the important parts of it here. Salt is just an ionic compound. And again, if you don't remember what ionic means, you definitely have to know what that means. So I would even just really quick, I usually write M plus NM, as in metal plus non-metal. That is what ionic means. You definitely have to know that. But it is an ionic compound that can be formed by neutralization. Essentially, it's just the other product. So we make water because you have H plus added to OH minus, but you also wind up with some extra stuff, and that extra stuff usually turns out to be salt. So I'm going to show you guys some examples here. the first thing that I would do is kind of learn to identify which things are acids, which things are bases, and what it makes. So I believe there's a couple. I'm trying to look because I'm trying to see if you see what I see. All right, so on your sheet, these little weird symbols right here, these A's, those show up as arrows. It should be an arrow. Just understand that on my side, and in this video, it didn't cooperate and it doesn't like that. So just understand that these are little yield arrows, like they're normally supposed to be. Oh, that was a bad one. I just don't want you guys to get confused here. So let me just change some of those. Okay. The first thing that we want to be able to do, just like normal, is be able to identify the acid and the base and the products. So like in this first equation right here, example number 1, it says HCl aqueous plus NaOH also aqueous yields and then blank, which we kind of have to figure out for ourselves. Before we even do that, though, we should be able to identify what these two things over here on the left-hand side are. I do see this H right here. That should tell me that it is an acid. So I'm going to write an A for acid here. If you want to write out the whole word, I don't really care. I'm just going to write out the letter because I'm lazy and don't have good handwriting. This other thing here, I see an OH. That's hydroxide. That should tell me that this thing is a base. So I'm going to write B for base over there. So I can already see that I've got an acid being mixed with a base. Now, from this little bit up at the top here, I know that that tells me that I get water. So what I usually try to do is, if I know that an acid and base are being mixed, I know that I'm going to get water at some point. So I'm going to write H2O right here, because I know that's what I'm going to get. I should wind up with some extra stuff. So now I should be able to figure out what exactly I'm going to end up with. Now, we already kind of used the H and the OH in order to make water. So we need to use the things that we're left over with. In the case of the hydrochloric acid, we are left with a Cl. And in the case of the sodium hydroxide, we're left with the sodium. Now, if you made the connection there, that means that the thing that we're left over with on the right-hand side is NaCl, which is a salt. So we have water right here, and we have salt right there. So an acid and a base mixed together always makes water and always makes salt. As you can see in the next couple of examples, though, examples 2 and 3, it's not always going to be that easy. And one thing that you're definitely going to have to make sure you can understand and do is that you not only figure out what's left over, as in water and salt, but you also need to balance the equation. You need to make sure that it stays balanced. This first example was really easy and it stayed balanced like kind of naturally, but you have to double check and you have to make sure that everything stays balanced on both sides. Let me show you exactly what I mean here. So number 2, I've got H2SO4 plus 2 of something yields K2SO4 plus 2 of something. Okay, so there's a couple places that we could start here. I'm going to start with identifying what we have here. A really, really easy way that you could figure out, for example, what H2SO4 is, if you haven't already pieced it together, you need to use the reference table. If you didn't immediately pick up that there is some H plus ions right here, then all you had to do was look over at your reference table. I believe that's table, oh god, I don't know if it's K or L. I think it's K. K has the acids on it. So table K in your reference table should have H2SO4. It should say sulfuric acid. So that one right there, I can already tell that's an acid. That means that this thing right here is probably going to be a base, although I'm not 100% sure what it is yet. I have no real idea, maybe, what this is right now. So I'm just going to leave that, but I know that regardless, this thing right here, this extra thing on the right, it has to be water, because I have to be making water in any of these acid-base reactions. I mixed an acid and a base together, I'm going to wind up with water at the end. So here, I know that that's water. Okay, and now I can piece this together and I can figure this out. First of all, if you didn't already label it and figure it out, that makes this thing, that makes that a salt, not like the felony, like the ionic compound. Okay, so we got salt, we got water, we got acid. We have to figure out what our base is now. And the way that you do that is you use everything that you have to figure out what you're missing. So for example, let me just kind of clean this up. Oops. Let me clean this up. Okay. So I can see that I definitely have some K's here on the right-hand side, and I have no K's over here. So that means there's got to be K's in this thing somewhere. And I want to make sure that the K's stay the same, and I can see that there are 2 K's. So if I know that there are 2 K's, then I'm just going to take a look. I should have 2 K's on the right-hand side. And just keep in mind, again, there's a little 2 here for us already. So if I want to have 2 K's on the right-hand side, that means all I have to do is put just a regular old K. Because now I have 2 K's on the left-hand side of the equation, and I have 2 K's on the right-hand side. So the potassiums are balanced now. If I take a look at some of the other things as well, let's see. Well, I can see that I have SO4 here. I can also see an SO4 over here, so that's balanced. I don't have to do anything funny with SO4. But we added water all the way over here on the right. Now, according to this 2, again, I'm going to pay attention to that little 2 in front. That means that altogether I have 4 hydrogens. So I'm going to put a little 4H just to remind me. And I have 2 oxygens, so I'm going to put a 2O. I know that looks like a 20, but that means I definitely need those amount of hydrogens and oxygens on the other side. We got to be careful though, because also on the other side I already have 2 extra H's, which we counted before. So that means I can get rid of those 2, and I can get rid of 2 of these H's. If you haven't figured it out either, the other thing that our base definitely has to have is OH minus, right? All the bases should have OH minus in it. Now, 2 H's and 2 O's together, like these 2 guys, should make 2 OH minus, right? However, again, I have this 2 right here, which means all I have to do is put O and H. Again, that's just a little like review, I guess, on balancing. Just make sure you know how to balance the equation. Make sure you're double checking that everything is balanced. If you wanted to go and check, the easiest way, by the way, to make sure that you balance correctly when you're done is literally just to take 60 seconds and just go back and say, are all the potassiums that I have on the left the same as on the right? Yes, they are. What about all the hydrogens? Are they the same on both sides? Yes, they are. That means we're good. But yeah, this should look perfect. Also, keep in mind that I did not put KOH minus up here. And I didn't do that for the same reason that this isn't H plus SO4. The idea is when OH is by itself, like this, it has a minus sign. But when it gets combined with a different positive ion, like K plus, if I add these 2 things together, that means we have KOH, and we don't have any charge because it's neutral, as in there's 1 plus that balances out with 1 minus. That means no charge. Again, just a quick reminder about a couple of things. I just want to make sure that everyone's kind of understanding why I'm doing some of the things that I'm doing. let's try again. That wasn't too bad. Let's try a slightly harder one. So we've got 2HNO3 plus something gives us CaNO3 2 plus 2 of something. All right, so again, the first thing that I'm going to do is I'm just going to label the things that I know. If I look on table K, that should be nitric acid, HNO3, so I know that that's an acid. And again, if you weren't 100% sure whether that was an acid or not, and maybe you're too, like, I don't know, maybe you're too lazy to go and check, that H right there tells me that it's definitely an acid. So that's my hint. I know that I'm also going to wind up having a base here, and I should definitely be making water somewhere. So that's what this is going to be right here. Oh, Christ. Here we go. That would make this remaining thing the salt. And now all I have to do is double check all of my balancing. I see immediately that there's a calcium here. So I'm going to start with that calcium. There we go, Ca. I can see 2 NO3s on here, and then that's 2 NO3s over here. So I know that means that we're good. I don't have to touch any of that. Let's see. I should have, again, 4 H's here and 2 oxygens there. So 4H, 2 O's. Those are definitely things that I need to have on the other side as well. But just like last time, there's 2 H's right here. So I don't have to worry about 2 of those H's. Maybe it's easier if I put like an equal sign just so that this doesn't look like a 20. So I should have 2 H's and I should have 2 O's. Again, that should equal 2 OH minus. I know that's like super sloppy. It should equal 2 OH minus. And I don't have a 2 in front, which means I kind of have to write it like this. Let's just, so parentheses, OH, close parentheses, and then a little 2. That's like extra super messy, so what I'm going to do is I'm just going to erase this, and I'm going to write it again with a little bit more space. Ca, and then I'm going to do parentheses, OH, close parentheses, and then a little 2. And keep in mind that that 2, I've written it that way because now I can tell that there's 1 calcium in this thing, and there are 2 hydroxide ions. And that 2 only applies to the things that are in parentheses. So it should look kind of like that. That's like the very beginning of how to write a neutralization reaction. So again, the most important things to remember are you have an acid, which has H+, you're adding it to a base, which has OH-, and you are always making salt, and you are always making water. Everything else is just kind of filling it in for now. So I think there's another couple of examples. Perfect. Write the equation for the neutralization reaction between dilute nitric acid, HNO3, and potassium hydroxide, KOH. So now this time, it's the same sort of problem as this, actually. These are exactly the same. The only difference is we're not giving it to you as an actual equation. We're giving it to you like a word problem. So you just have to write the reaction yourself, but it is the same. So here, so it's saying we have this acid, and we have this base. So hold on, this is the, ooh, Jesus Christ. We have this acid, we have this base, we have to write the neutralization reaction for both. So the way it's going to work is that we're going to start, I'm going to write the acid in red again, HNO3. Oh my god. There we go. Plus Oh god, I can't write to save my life. This pen is so difficult. Okay, the base, which is KOH. Again, I'm writing it this way because an acid plus a base is what a neutralization reaction is based off of. Should yield, well, I know it yields water, so I'm going to write water. And I know it's going to yield a salt, something else. I don't know what that is yet, so it's going to be, you know, something. So the first thing that I have to do is I have to figure out what the missing thing is. I can see that I have the OH plus the H. Those add together to give me my water. So I don't have to worry about those. But the other two things, the nitric acid and this potassium, I didn't use. So why don't we put that right over here. KNO3. There's a couple things you have to keep in mind, though, when you do this kind of reaction, and you have to make sure that all the charges are balanced out. And when I say that, I mean, like, for example, kind of like what we said before, where the OH minus has to balance out with, for example, a K plus. What you have to do is you have to check the charges on your reference table. For example, if you go to table E, I believe NO3 has a charge of just a minus sign. And K, if you check the reference table, like the periodic table, the oxidation state, it's +1. This one worked out really, really easily. As in, K has a +1, and NO3 has a -1. But it's not always going to work out that way. And if it doesn't work out that way, it might be a little bit more difficult. It might be a different problem. So what I'm going to say is just write it out the way that I've done it, for example, to start with, and definitely check your charges and make sure that your charges match up, because if they don't match up, you're going to have to play with it around a little bit. But let's keep going. It says, write the equation for the neutralization reaction between dilute MgOH2 and HCl. Okay, so first, again, let me figure out HCl. That should be real familiar, hydrochloric acid. And I see some OHs in this thing. That is a base. So I'm going to start by writing acid and base first. So just like before, HCl plus our base, which is going to be MgOH2. Oh, that was beautiful. Let's fix that a little bit. Okay. Should yield. Okay, well, again, I know it has to yield water. And it's going to yield something else. Okay, so the first thing that I have to figure out is what that last thing is. Now again, the H plus ions and the OH minus ions are going to make up our water. So let's look at the other things. The other things, by that, I mean the chlorine and the magnesium. Those two things are going to be over there. MgCl. There's a problem here, and if you've picked up on the problem already, that's really awesome. If you haven't, take a closer look. How many H plus ions do I have on the left-hand side of the equation? And I'm not talking about things that are paired with O, like OH. I'm talking about H's just by themselves. We are looking at one hydrogen ion. That's fine. How many hydroxide ions, or OH minuses, do I also have on the left? Well, there's my hydroxide, but I have two of those. So I have two OHs, and I have one H. That's like doing this. I have the H plus ion over here, and I have two OH minus ions. So now these two are fine, because if I add these two together, I should get a water. But what about this one? This one has no H plus to pair with it, so it just sits by itself. So that's not balanced. So I have to do something here to make it balanced. Again, if you're not 100% sure, take a look at what I did just above it. I needed an H plus, and I needed to add it to an OH minus. So that means I should get another H plus ion so that I can add it and make a second water. That means we're going to have to change our reaction just a little bit. We need to double the amount of H plus ions that we have. 2 HCl. That gives us our second H plus ion that we needed, and it also makes 2 waters. So careful, that means we definitely need to put a 2 in front of that. Now, that covers our waters and our OHs and our Hs. Like, if you double check them and you go back, all of our Hs and Os should be balanced now. That was super messy. Whoa, what did I just do? Okay, all right, so now we've got our 2 HCl's, we've got our 2 waters. Okay, good. There's one more thing I think we need to fix about this, and unfortunately I just kind of screwed it up so that I'm going to have to write over it, but okay. All right, good. So our problem here is that not only did this 2 right here make 2 hydrogens, but it also made 2 chlorines. So we got to be careful because now we have 2 chlorines on the left and we also have 2 chlorines on the right. So that's going to be kind of a problem here. I mean, it's not a huge problem. Actually, if you were to check the oxidation states for magnesium and chlorine, and again, I'm kind of running out of space here, but magnesium has an oxidation state of 2 plus, and chlorine has an oxidation state of minus, or 1 minus. So that right away should have told you we needed 2 chlorines in order to double that negative charge. So that means all we actually have to do, I'm going to have to cross that out. Sorry, I wish I could erase it. It should mean that this thing should actually be MgCl2. So it should read, the whole equation should read 2HCl plus MgOH2, like I have here, yields 2 waters, 2H2O, plus MgCl2. That's the whole reaction. And again, that all comes from just knowing like that you have to balance it. Just make sure that your equation's balanced at the end. Okay, so I deleted all that. That's good. All right, perfect. Let's move on to the practice here. And again, just as a quick, here, let me just fix this. I don't know why it picks like a different symbol every time. I don't know what the deal is. But that just should just be an arrow. And I'm pretty sure it's an arrow on your sheet. It just doesn't work on mine. Same exact thing. They give us an equation. We just have to fill it in. And we should be able to label which things are acids and which things are bases. That should be the easy part. So again, really quick, what I should be doing is I should be looking for H plus ions. That's this thing right here. So that means, oh, hair. That means this should be our acid. I see an OH over here, so that's our base. I see our water. That means this thing right here is going to be our salt. Now, I just don't know quite what it is yet. So what I have to do is I have to look for the stuff that we didn't use in the reaction. And because we already made water, that means we already used our H pluses and our OH minuses. So if it makes more sense to you, I used that H already, and I used these OHs, which means I'm only left with one BA and two CLs. So it should be BaCl2. And keep in mind that if you didn't quite look at it the right way, and maybe you weren't sure that you were supposed to have 2 chlorines, the other way that you could have done it is you could have looked up Ba which again has an oxidation state of 2 plus, and chlorine, which has an oxidation state of 1 minus. And you can go, hey, that means I need 2 of these guys right here, which means the whole reaction, or I'm sorry, the whole compound should read BaCl2. And even if you just take a quick look back at your equation when you're done, if you had happened to just put BaCl, hopefully you would have noticed that there are 2 chlorines on the left, and you would have only had 1 chlorine on the right. So that might have tipped you off that you should have probably changed that compound to BaCl2. Cool. Let's get rid of that. Oh, that's the whole page. Okay, cool. Let's go to the next one. Okay, so second page. Again, gives us a little bit of practice. I'm going to zoom in because all I care about is the practice right now. That part right there, actually, the barium hydride, that's just the names of the stuff from the first problem, so we actually don't even need that right now. Cool. Okay. Can I zoom in more? Do I have enough room for that? Sweet. All right. So number 2, 2AlOH3 plus 3H2SO4. Again, this should be an arrow. That's an arrow. Why are they little R's? Oh, best arrow. I'm just going to awkwardly make arrows here for a second. Hold on. You think, as a teacher, I would be really good at multitasking, and I'm not. Okay. Cool. All right. So we've got 2AlOH3, 3H2SO4, we've got Al2SO43, and we've got 6H2O. So it tells us all the names down here at the bottom as well. Aluminum hydroxide plus something gives us aluminum sulfate and water. So easiest way to do it, again, is just to look at which is an acid, which is a base. If you go on table K and table L should tell you aluminum hydroxide is our base, because it has the OHs. It should also tell you that H2SO4, I think that's sulfuric acid, right? Sulfuric acid. Oh, my handwriting is so neat. Anyway, that's our acid. That's our water. Check. That makes this our salt. Awesome. So actually, that was the only part of the, okay, beautiful. So that's it. That's all they wanted us to do, was just find the name of that. So that's just as simple as going on table K and looking up what H2SO4 is. Okay, so let's look at number 3 then. We've got this thing. It says iron 2 hydroxide plus, it kind of, again, it gives us a little bit of a hint, phosphoric acid. And all we have to do is fill it into the equation. So if you take a look, actually, phosphoric acid should be, what is that, PO4? And we should also figure out what else we're missing, as in, I have 3 irons on the left, I have 3 irons on the right, so that's good. I have my OHs, which are going to show up in my water. That means that, especially since this is an acid, I should have some H here, some regular old hydrogen. So we're going to put a little hydrogen here. Now, there's a couple ways that you can do this, because the answer is not going to be HPO4, because it's not balanced correctly. And the way that you can do that is you can either balance it, as in you can look like, how many hydrogens do I have on the left, how many do I have on the right, and balance it that way. And you can also do the same thing with PO4s, or You can also look up the oxidation states. So give me a second and I'll do both for you. The first thing here is I notice that we have two PO4s on the right-hand side, right there. That means I should have two PO4s on the right-hand side. That could mean one of two things. That could mean I can either put this in parentheses and put a little 2 at the bottom, or I might be able to move that 2 in front. I guess it really depends on how many hydrogens I need. Let's leave it like this for now, and we'll figure out how many hydrogens. Over here on the left, it says I have 2 OHs. That means a total of 2 hydrogens and a total of 2 oxygens. Oh, why did I draw an 8? I don't know what's wrong with me. And again, I'm ignoring the oxygen from the PO4 because that's taken care of right over here. Like, that's all balanced. So I don't have to worry about that. We can kind of treat PO4 like its own identity. Like, I don't have to mess with that. In 6H2O, that right there is 12 hydrogens and 6 oxygens. I also have to be careful because there is a 3 in front of this guy all the way over here. So what I'm going to do is I'm going to multiply my hydrogens and oxygens by 3. That means 6 of each. So my oxygens, as you can see, are both 6, as in I don't have to touch those. We kind of already knew that only because like we knew our OHs were going to balance out for water anyway. But regardless, we have 6 hydrogens on the left. We have 12 hydrogens on the right. That means we should also put 6 hydrogens here, right? Because I should have 6 hydrogens on this guy right here, this thing, and I should have 6 hydrogens on this thing. And when I add them together, I can get the 12 hydrogens that I have on the right. That's all just balancing. So there's a couple of ways that I can do this. I can't really put a 6 in front of this because that would also apply to my PO4. What I can do, because I'm supposed to have that 2, is why don't I just do this? Let's take the parentheses off. Let's move the 2 in front of the whole thing. Now I have 2 PO4s, which is what I wanted over here. So that still checks out. And I want 6 hydrogens, so I should probably also add like a 3 down here. So now my hydrogens are 6, which is what I wanted, right? And my PO4s are 2, which is also what I wanted. If you were to check everything that's here, it would be balanced. So like again, if I just run through like checking, all of my irons would be balanced, all of my oxygens would be balanced, all of my hydrogens would be balanced on both sides, all of my P's and my O's would all be balanced. Like everything is balanced on both sides. I have the same number on the left and the right. And again, that really just requires you to check. The other way that you could check this out is you could look at PO4 on table E. PO4, if I remember correctly, should have a charge of 3 minus. And hydrogen, as we should probably know by now, has a charge of just a single plus sign. And in order to balance this thing out, I need 3 hydrogens, right? Because I should multiply this whole thing by 3. That gives us the H3PO4. You still kind of had to figure out that you needed 2 of those by checking your balancing, but that still kind of helps you out. So if either one of those methods makes sense to you, then that's good. Again, the biggest tip that I can give you is that you need to check your work at the end, and you need to make sure everything's balanced. You should have 1 acid adding to 1 base that gives you a salt and some water, and everything should balance out and equal each other. Let's go to this last practice problem here, and then we'll move on to some more Regents questions. We have CaOH2 plus something gives us CaNO32 plus 2 waters. So the first thing I'm going to do, I'm just going to label my acids and bases really quick. I see this has an OH, that makes this the base, so I can assume that this is the acid, and it kind of also tells me nitric acid. If you go ahead and you double check, I'm just going to label those really quick, salt and water. If you go ahead and you check what nitric acid is, you should get HNO3. HNO3 is nitric acid. I think that's table K, right? I can't remember which is which, and I'm too lazy to pull it up, but I think it's table K. So now, again, we're not done. The only thing that we have to do is we have to make sure that we're balanced. So that's what I'm going to do really, really quick. First things first, I have calcium over here, I have calcium over here. That checks out, so I don't have to worry about the calciums. I have OH2, as in, if I have two waters over here, that makes sense. That means I have 4 hydrogens, and it means I have 2 oxygens. That's just on the right-hand side. So again, I'm just keeping track of how many of each thing I have. If I have 2 OHs on the left, that means I can get rid of 2 oxygens, which is all of these, and I can get rid of 2 of these little hydrogens. I still got to keep in mind that there are 2 hydrogens that I haven't accounted for. If I keep going, my NO3s, there's one NO3 that I have here. I immediately can see that there's a little 2 outside of that NO3. And again, I still need 2 hydrogens, and I only have 1 over here. Hopefully you figured it out. But that means that we should have a 2 in front of our nitric acid. Now, if we were to double check everything, all of our hydrogens would balance out, all of our nitric acids would balance out, the N's, the O's, everything is balanced. So it should look like this. I almost just asked if you had any questions, but that's not very smart because I'm literally talking to an inanimate object. But yeah, let's just keep going, I guess. Okay, so we got a couple of regions questions, and we have 1 or 2 things down here at the bottom. I'm going to run through that really quickly. If you think that you're comfortable with it and you want to do it yourself, like go ahead and do it yourself. And if you happen to run into any issues with some of these questions, then maybe check back in the video and see how I explain it. But if you've got a handle on it by now, you don't need to follow every step of the way if you don't want to. All right, so it says, which acid and base react to form water and sodium sulfate? So this one, you could do this a couple of ways. You might find it easier to write out the actual reaction. You might also be able to, there are some people that can probably pick up a couple of shortcuts from this at this point, but I'm going to write out the whole reaction just so that you can see it. I think that's probably the most helpful. But it says at the end, we should make water, and it says we should probably also make, it says sodium sulfate, what is that, NaSO4? And again, that's me going to table E. Sulfate is SO4, and I know sodium has to be attached to it, so that's NaSO4. But yeah, so what we should definitely have, as far as base goes, right, our base definitely has to have an OH minus ion, and our acid has to have an H plus ion. I happen to know, if I'm looking on table L, and also kind of from memory because I do it all the time, but if you look on table L, NaOH is a very common base. That's sodium hydroxide. So that's a really quick thing that you can just check on table L. Table K should have HSO4 as well. That's sulfuric acid. Or, yes, sulfuric acid. So that should give us our answer right there. Sulfuric acid and sodium hydroxide. That means it's going to be this one. Sulfuric acid and sodium hydroxide. It says, what are the products when potassium hydroxide reacts with hydrochloric acid? Again, this is probably easiest to just write it out. For this particular question, you probably don't even have to balance the reaction. I don't know, I don't even know offhand if it balances nicely or not, but they're just asking for the products. So if I write it out, potassium hydroxide, again, if you're not sure what those things are, I'm kind of writing them from memory because I see them so often. But if you just look at table K or table L, like it tells you the names and it tells you the formulas. So potassium hydroxide should be KOH. Hydrochloric acid we should know as HCl. And the things that we make, number one, I hope we understand that we make water at this point. It should always be water. So I can already see that it's not this one and it's not this one because those don't have water in it. This one kind of doesn't seem to make sense because it's like a bunch of like stuff. I don't really know. So I can kind of, even just from process of elimination, understand that I should be making KCl, which is the leftover from this and the leftover from this, like together. But it's definitely going to be choice 2. Which solution reacts with LiOH to produce salt and water? So this is again kind of a vocabulary, I suppose. I know that this is a base because it's got OH in it, which means my answer needs to be an acid because I should have an acid combining with a base. So automatically I can tell that this is not an acid, this is not an acid, and that's not an acid. So you didn't even have to really do that much. You just have to know that, oh, I need an acid and I need a base to combine together. So all I have to do is figure out what the acid is and what the base is. But yeah, this is a salt. It's not on table. It's not on table K. This is nothing. I don't know what that is, and this is a base. So that means it's got to be sulfuric acid, H2SO4. Which compound is produced when hydrochloric acid is neutralized by CaOH2 or calcium hydroxide? So I definitely should be writing those out really quick. CaOH2. We should know that I get water. I could just double check to see. I don't see water as an answer choice, unfortunately, because that would be easy. But so what they're saying is we need to find the salt, the extra thing that's at the end. So again, I should probably be ignoring the H from the HCl, as in I'm using chlorine definitely, and I should also be using the calcium, which is the other leftover thing, CaCl. And again, you kind of get the answer at this point, but if you weren't sure of the formula, like if you don't know where they got CaCl2, that's, again, you could check the reference tables. Calcium should have a 2 plus, chlorine should have a minus. That means you need 2 of these guys to cancel out with the 2 pluses. CaCl2 is the answer. There we go. It's going to be that one. All right, word. Let's continue. I think we only got this little bit left and then we're done, which is nice. It says a sodium hydroxide, or NaOH, solution and an acid-base indicator are used to determine the molarity. I think that says of an HCl solution. Let me just scroll to where you guys are. Okay, yeah, of an HCl solution. It says a 25 milliliter sample of the HCl is exactly neutralized by, that is 15.0 milliliters of 0.20 molar NaOH. It says complete the equation for the neutralization reaction that occurs by writing a formula for each product. So this is a great example of a question that, in this particular case, they give you a lot of things that you don't need. For example, we've seen this question before. Honestly, that's not what I wanted. Sorry, hold on. I was trying to write, but I'm an idiot. So, like, if I did this, for example, and I say this all the time, and it's not just like in this topic, but if I cross this out and just block it from my mind for a second, and I only read the question, what does the question say? The question just says complete the equation. by writing the formulas for each product. You don't have to do any math. There are probably questions that were attached to this, and we're going to learn how to do stuff like that. But for now, just don't get like intimidated because they gave you a bunch of numbers. You don't need any of those things in order to solve the problem. They said complete the equation, so let's just complete the equation. If I label them, HCl should be pretty easy by now. It should be an acid, and sodium hydroxide is a base. So that means I'm definitely making what? Definitely making water, and I'm making some sort of salt at the end. So we got our water, we got our salt, we got our acid, we got our base. Okay, good. I just have to figure out what I'm left over with. Hopefully you figured out that we're definitely going to be using the sodium and we're definitely going to be using the chlorine. It was the exact example, actually, that I gave you guys before. So sodium chloride is the salt. That's it. Once we get to like titration and a couple of other things, we'll talk about the more like technical parts of neutralization and how exactly like the numbers come into play. But for now, the whole idea behind neutralization is just understanding that when you add an acid to a base, it makes water and it makes salt. And you need to be able to identify what's an acid and what's a base in order to predict what kinds of things are going to be made at the end. But yeah, I'm going to cut this short because I know that was like a lot of talking, and I want to take up all your time. But yeah, hope this worked. Cough, cough. Remember to like